Hey everyone, welcome to another video. This is the second video on the Precalculus series here on this channel. Okay, so today we'll be talking about 1.2 rates of change. Okay, so to get started, let's first define the average rate of change. So the average rate of change, also known as the slope, is the rise over the run, which is just the change in y over change in x, which is y2 minus y1 over x2 minus x1. Okay, so these are all the average rate of change. There's different ways to represent it. Okay, so let's do an example. So let's say we have some graph, right, like this. So this is y equals f of x. And let's say we have to find the average rate of change between the point 0, 0 and say like 3, 2. Okay, so the average rate of change is just the slope between this. So if you draw the secant line between these 2 points, oh, it's horrible. But like, you get the idea. So if you draw the secant line between these 2 points, and so that's the average rate of change, is the slope of that line between these 2 points. So it would be m is equal to, so this is your x2, y2, and this is your x1, y1. So in the formula, you can just plug in the numbers now. So you have y2, which is 2, minus y1, which is 0, over x2, which is 3, minus x1, which is 0. So you get 2/3 is the average rate of change. Okay? So another example. So this time, let's say you have like a table. So let's say you have like x and then f of x. So 0, 1, 2, 3. And let's say f of x is like 0, 1, 8, 27, right? So, and let's say you want to find the average rate of change on the interval from 0 to 3, right? So how do you do this? So same concept really. So this point 327 would be your x2 y2 point, and then the point 0, 0 would be your x1 y1 point, because that's the start of the interval and that's the end of the interval. So the average rate of change, or the slope, is just y2, which is 27, minus y1, which is 0, over x2, which is 3, minus x1, which is also 0. And you get 27 over 3, which is 9. Okay? Alright, good. So now let's move on to the next topic, which is the average rate of change at a single point. So, for example, let's say you have some function f of x equals x squared minus 5, right? And let's say you want to find the average rate of change at x equals 3, right? So average rate of change, here, I do like this. Average rate of change at x equals 3, right? So at first glance, it might seem a little tricky as to how to do this, because when you do average rate of change, you almost always have 2 points, but here you only have 1 point that you're looking at. And so the key idea, the way that you do this, is that you take your first point, x1, which is 3, and then your second point is going to be a point that's very close to the first point. So x2 has to be very close to x1. So you're almost like approximating it. It's not going to be exact, but it's going to be very close. It's going to be a really good approximation. So, and the closer to x2 is to x1, the better the approximation. So if we start off with like 3.5, we do like 3 different approximations just so you can see how the approximation get better and better. So we can start off with 3.5, then you can go to 3.1, and then you can do 3.001, right? So each of these will give us a better and a better approximation. So our y1, so you put 3 into here, 3 squared 9 minus 5, 4, and then I'll put the y2 for each of the corresponding x2s. So if you put 3.5 into here, my calculator, you get 7.25. Okay, if you put 3.1, you get 4.61, and then 3.001 gives us 4.006. Okay? Alright, good. So now let's, for each of the x2, y2 points, we can approximate the average rate of change at x equals 3. So we'll start off with the first point, which is 3.5, 7.25. Okay, so we get y2, which is 7.25, minus y1, which is 4, over x2, which is 3.5, minus x1, which is 3, and you get 6.5. Okay. So next, let's use the second point. So we'll use 3.1 and 4.61. So you get the slope. Average rate of change is approximately y2 minus y1 over x2 minus x1. And this gives us approximately 6.1. So notice real quickly how it went from 6.1 or 6.5 to 6.1, right? So it's almost as if we're getting closer and closer to 6 as we get, as x2 gets closer and closer to 3, right? So then let's verify this by doing the last point, which is going to be the best approximation for our case, which is 3.001 and 4.006. Okay, so this gives us y2 minus y1, which is 4, over x2 minus x1, and this actually gives us exactly 6. And so now you can approximate that the average of change at x equals 3 is approximately 6. Right? Okay, good. Alright, so now let's move on to positive and negative rates of change. Okay, so if you have positive rate of change, right, so let's just illustrate this with a graph. So it would look something like this, right? There's better. Okay, so essentially this is the x-axis, this is the y-axis. So as x is increasing, y is also increasing, right? And then as x decreases, y also decreases. So essentially, positive rate of change means whatever x does, y does the same thing. Okay? And also like here, the slope is positive, right? That's why it means like positive rate of change, is because the slope is greater than 0. So the negative rate of change so here the slope is negative, right? And graphically it would look like something like that. All right, so this is the x-axis, y-axis. So now notice how that as x increases, y is actually decreasing, right? And then as x decreases, y increases. Okay, so now let's do some practice with this. So let's say, so I'm gonna give you some scenarios and you can decide whether it's positive or negative rate of change. So the first one, let's say, is like a child's height over time, right? So is this a positive rate of change or a negative rate of change? Well, to start, you can notice that time is always an increasing variable, right? Time can never decrease, it's always increasing. So now let's see height. So over time, a child's height is going to increase, right? They're only going to get taller, hopefully. So height is also increasing. So now notice, so time is our independent variable, and height is our dependent variable. So as our independent variable increases, our dependent variable also increases, right? They're doing the same, they have the same trend. So this is going to be positive rate of change. Okay, let's try another one. So now let's say like, I don't know, like number of pizza slices at a party over time. So again, you're dealing with time as your independent variable, and then number of pizza slices is your dependent variable. So again, time is only increasing, so time is our increasing variable. And then number of pizza slices, well, more and more people are going to eat pizza, so the number of pizza slices is going to decrease, right? So then as x increases, y decreases, so this is negative rate of change. Okay. All right, and that concludes today's lesson, 1.2 rates of change. Please make sure to subscribe and hit the like button. See you next time.